Alright, inverse trig functions. I apologize, I just had a big lunch of donuts. I would not recommend that. If it sounds like I'm laboring to breathe, just ignore it. So, we've dealt with inverse trig functions before. We have used them to find acute angles. But what if we want to find an angle that's not an acute angle, or what if it's not an acute angle that we're dealing with? So what we're going to look at now is formally defining the inverse of a trig function as its own function. There will be restrictions on this though. So first we want to learn some notation. The inverse notation, again, we've used this. We've used these to find the angle on our calculator. This is the inverse function. Theta equals the sine inverse of z. Another way to write this is arcsine. So arcsine and sine inverse are the same exact thing. There are two ways to write the same exact thing. Either one works. You will see both, so you need to understand both. Same is true for our cosine inverse and our cosine, tangent inverse and our tangent. We will not be doing inverse functions for secant, cosecant, and cotangent. They do exist. We aren't going to be dealing with them in this class. So theta equals the arcsine of z. This is only true, so if and only if the sine of theta equals z. So this is the sine function, this is the arcsine function. They are inverses of each other, but they are two different functions. The arcsine, or inverse function, will have an output that is an angle and an input that is the ratio of sides of a triangle. The trig function, the regular trig function, not the inverse, will have an input that is an angle and an output that is the ratio of sides of a triangle. Same will be true for our cosine, and same will be true for our tangent. So now I want you to take a minute and recall what is the definition of domain, or write down domain in your own words. What is the definition of range in your own words? What is the domain of the sine function? Not inverse sine function, but the sine function. What is the range of the sine function? And how do domain and range relate? How do the domain and range of a function relate to its inverse? So I want you to write down all those. So pause the video, write down what you remember, unpause when you're ready to discuss. Okay, so hopefully you remember that domain is all of the possible input values for a function. The range is all of the possible output values for the function. So what is the domain of the sine function? The domain of the sine function is all real numbers, or you could write it negative infinity to infinity in interval notation. Why is that? Well, think about what are we inputting into the sine function? We're inputting in angles. And think about our circle. That the circle goes from 0 to 2 pi, but then it continues to go around. So you can go around the circle as many times as you want. You can input any of those angles. You could also think there's an infinite amount of coterminal angles, there's negative angles, all of those work. So domain is all real numbers. The range, though, is negative 1 to 1. It includes negative 1 and it includes 1. But for sine, there's never going to be a value larger than 1. Why is that? Well, you can think about it in terms of sides of a triangle, or you can think about it in terms of the unit circle. That the largest the y values go is 1, the lowest the y values go is negative 1. How do the domain and range of a function relate to its inverse? Remember this from the last unit. The domain of a function is the range of the inverse of that function. The range of the function is the domain of the inverse of that function. Okay, so next we'll do a little experimentation. So given the following, solve for theta in radians on your calculator, round to 3 decimal places. So we have sine of theta is 0.7, sine of theta is negative 0.7, and sine of theta is 1.7. So remember to type this into our calculator. We'll go to our calculator, change your mode to radians because we want our answer in radians. And we'll quit. And we'll go here. So we've sine of theta equals 0.7. Then remember theta equals sine inverse of 0.7. So that's what I'm going to type into my calculator. So I'll do second sine 0.7 and I get 0.775. Alright, so I want you to do that for B and C, and then I want you to look at those three answers and see if you notice anything, or try to write down any observations that you come up with. So I want you to pause the video and do that real quick. Okay, so for part B, you should get theta is negative 0.775, and for C, you should have gotten an error on your calculator, which means that theta does not exist. And we'll talk about that in a second, but that maybe should make sense to you, since this value 1.7 is larger than 1. So what are some things we notice? We get a positive answer here, we got a negative answer here, and we got an error, which means that the value does not exist. So there are three different possible scenarios here. A key thing to notice is the negative also. So before we've only had positive acute angles, or acute angles which are positive. This is not an acute angle because it is not positive, although this would be between 0 and pi halves if we took the absolute value of it. Alright, so this leads us to the domain and range of the inverse functions. So theta equals the arc sine of z, remember that's the same as the sine inverse of z, has a domain of negative 1 to 1, including negative 1 and including 1, and a range of negative pi halves to pi halves, including negative pi halves and pi halves. The arc cosine function has a domain of negative 1 to 1, including negative 1 and 1, and a range of 0 to pi, including the 0 and including the pi. And the arc tangent function has a domain of all real numbers, and a range of negative pi halves to pi halves, not including the negative pi halves and pi halves. You will need to know these. So those are on your sheet, but do you notice anything about the domain of the inverse function compared to the range of the original function? And do you notice anything about the range of the inverse function compared to the domain of the original function? So write down any observations that you have, pause the video, unpause when you're ready to discuss. Okay, so what I hope you notice is that the domain of the inverse function, so if I look at the domains right here, the domains of the inverse are the same as the range of the original functions. Negative 1 to 1 is the range of the original sine function, negative 1 to 1 is the range of the cosine function, and all real numbers is the range of the tangent function. However, the range of the inverse functions is not the same as the domain of the original functions. So again, if we focus on sine, the range of the inverse is negative pi halves to pi halves, whereas the domain of the sine function is all real numbers. So this is just a small portion of that domain. And the same is true for the cosine inverse and the tangent inverse. And without seeing the graphs of the trig functions, which we're going to get to in the next unit, this relates to when we were doing inverse functions in the previous unit, and sometimes you have to restrict the domain of the original function in order for the inverse to exist. The same thing is happening here. So for now, you just need to understand what the domain and range of the inverse functions are. So here, I want you to solve the arc sine of negative 0.75 equals theta. Use your calculator, find your answer in radians, round to 3 decimal places, pause the video, unpause when you're ready to check the answer. Alright, so hopefully you got theta is negative 0.848. Great. Why are we doing that? Because we're going to compare it to this problem. So this is a slightly different problem. Using a calculator, find theta in radians, where theta is between 0 and 2 pi, and the sine of theta is negative 0.75. So how is this different? Well, we've done problems like this where we found theta from the unit circle. Now we're using our calculator. I know that if I type into my calculator sine inverse of negative 0.75, I'm going to get negative 0.848. But this is not within my domain here that I'm using, or within the range that I'm using. So, what do? Well, I use this to help me understand the reference angle. So I know that the sine inverse function is restricted to negative pi halves and pi pi halves for a range. So where is negative 0.848? That's somewhere down here. It's this negative angle. But what is the reference angle of that? 0.848. So I can use the reference angle to find two positive angles between 0 and 2 pi. Where is sine negative? Sine is negative in third and the fourth quadrant. So I need to find this angle, and I need to find this angle, but both of them have a reference angle of 0.848. So I can say the green one, theta equals pi plus 0.848, and the blue one, theta equals 2 pi minus 0.848. And I can type those into my calculator and get an answer. So I get 3.990 and 5.435. So then we have the question, why is it okay to find theta solutions outside of the range of the arcsine function for this problem? The reason why: the original problem did not have the arc or inverse function. So if the original problem has the arc or inverse function, you are restricted to the domain and range of the inverse function. If the original problem does not have that, but you use the inverse function in order to find your solutions, then your restrictions are a little bit looser. You need to understand that when I type this into my calculator, it will give me an answer within the range of the inverse function, but that might not be one of my answers to the problem. It might just help me find one of the answers to the problem. Alright, so now we're going to do this without the calculator. So we want to, this is what we've done before, we want to use the unit circle to evaluate these. That's why we're not using a calculator. But we want to pay attention to the domain and range of the inverse functions. So I want you to try to do that. Pause the video, use the unit circle, unpause when you're ready to check your work. Okay, so what is the arc cosine of 0? It is pi halves. How do I come up with that? I use my unit circle. Cosine is the x value. Where is the x value 0? It's 0 at pi halves and 3 pi halves. But 3 pi halves is not within the range of the arc cosine function. So I'm stuck looking at just the top half of the circle, and so I have pi halves. What is the arc sine of 0? That is going to be 0. Again, I'm restricted to the range of the arc sine function. So where is the y value 0? It's at 0, not 2 pi. 2 pi is not within the range. The arctan equals -1. Well, remember, arctan has a similar range to sine. It is negative pi halves to pi halves. Tangent equals -1 at 7 pi fourths. 7 pi fourths is not within that range, but the coterminal angle of that negative pi fourths is. Now I do the same thing for arc cosine of -1/2. Look at the top of the circle. That's going to be at 2 pi thirds. Sine inverse of root 2 over 2. Look at the right half of the circle. That's going to be at pi fourths. Tangent inverse of -root 3 over 3. Look at the right half of the circle. It's 11 pi sixths. The coterminal angle is -pi sixths. And cosine inverse of 2 does not exist because 2 is outside of our domain. Okay, so inverse function always equals an angle. And the domain and range only apply if the original problem has the arc or inverse.